2-4 today, one variable equations and inequalities. If you once again recall, for those of you here this summer, and I talked about those days where we will spend an entire day on about a half a chapter of algebra. This is that other half a chapter. So here we go. Some of you are going to really recognize it. Some of you are going to not quite remember it. You're going to have to study it up a little more. Some of you this is going to be very easy, and some of you it'll be very difficult. So just a quick reminder, when we're dealing with equations means there's an equal sign, whereas an inequality means it's an inequality symbol of some sort. Okay, it's a not equal sign. So you could have that one here, there's this one here, and then there's this guy here, and that guy there. Okay, these on this side that point to the left, anyone remember? They are less than. Left means less. Okay? If it points to the left, it means less. If it has the little piece underneath, that means or equal to. Okay? So less than here, less than or equal to here. Okay? Hopefully that's a review. If it points to the right, it is greater than. Okay, greater than. So we have greater than or equal to right up here. And then you have your equal to. There's one other inequality symbol. It looks like this here. It is a not equal to. Well, that's an inequality symbol. An equal to is an inequality symbol. So we use that with equations. Inequalities would imply one of these four symbols. Okay, hopefully that's not anything major and new to you. Really quick, for those of you who need another way of remembering your inequality symbols, if this is a number line, those little arrows at the end of number lines are strategically placed. The positive side, bless you, and the negative side. The one on the positive end is a greater than symbol. The one on the negative end is a less than symbol. Okay, if you didn't know that, it's a good way to remember them. Okay, if you're like me and you go through high school not really remembering what those mean, then that's kind of a bad strategy, a bad approach. If you're still the alligator person, the alligator eats the bigger number, that's fine. Just know what the alligator's name is, less than or greater than. Okay, and just because you know its name, if you find one walking down a street somewhere in the South, don't go up and talk to it. Okay. Very dangerous. All right. Yes, just life lessons. All right. Page 275. You don't need a book today, but we're going to go through this if you need to look it up later. But solving and graphing equations and inequality. Remember, a solution to an equation or an inequality is when it makes a statement true. So in an equation, x equals -2, that would mean that your equation would be true for only the value -2. If you put any other number in, it wouldn't work. Whereas in an inequality, you have a range of numbers. So in an inequality, for instance, if the solution was x is greater than -2, that would mean any number that is greater than -2. Tell your neighbor a number greater than -2. -1. Okay, anything other than -1. Okay, how about 10? Does 10 work? Yes. So, note the difference in the way we show those. Right back here now. Note the difference in the way we show those solutions. X equaling -2, we put a dot on -2. Versus x equaling or is greater than -2, we shade everything to the right of -2. Pay attention, quit talking. Jaden, turn this way. Okay? So we shade everything to the right of -2, and we put an open circle here versus when we have an equal to, we put a closed circle. So if we had a little line under this, it said x is greater than or equal to -2, we'd have to close that circle because that means -2 could be a solution to it. But since that equal sign isn't under there and it just says is greater than, we have an open circle, meaning x cannot be -2. It would not be a solution to that inequality. So in this statement, negative 2 is not a solution, but anything bigger than negative 2 is. That's why we shade it. In this one, negative 2 is a solution, as well as everything smaller than negative 2. That's why we have an open circle, or a closed circle. Okay? So if you're thinking of your symbols, once again, this guy and that guy, those are closed. That guy and that guy, those are open. We could also add the equal sign here, that would be a closed circle, and the not equal to sign down here, that would be an open circle. So when you're graphing these three symbols, you have to include that number as part of your solution set, therefore we close the circle. These three symbols, we do not include the number as our part of our solution set, so we have an open circle. Now I'm hoping all of that is all reviewed to you. Okay, for some of you it's been a long time, some of you it's been a shorter amount of time. But any questions so far? Okay, with that I want you to graph these three on a number line. You can work with your groupie. Here you go. X is greater than or equal to negative 7. The way I ask you to graph them, I don't really need you to be so precise that it takes you forever. I just need to see 0. I need to see the number. Okay, if the number happens to be 0, then put another number beside 0. Okay, I need to see 0. I need to see the number. I need to see open or closed. In this case, it's closed. And notice if the variable is on the left, a trick is the arrow always points in the direction you shade, as long as the variable's on the left. Okay, so it's everything greater than, and you could always test it. You could put 0 in. 0 is greater than or equal to negative 7, so you shade that way. Now, I know that there's some people that shade like this. There's some people that shade like this. They put their little 0 and negative 7, and they put their closed circle, and then they do their little like that. That's fine. Doesn't matter to me. So, however you want to shade. I think the scribble is fun. It's one of the times in life you get a scribble and not get yelled at. Okay? 0, 5, not equal to is open. So what could be a solution? Tyler?
Everything but 5.
Everything could be except 5. So you shade in both directions. The wicked step cousin of one direction. Okay? And letter C. This one we have x has to be less than, or excuse me, greater than or equal to 4, but less than 10. So in this one, we're going to put our 0, and notice I'm going to shift it this way because I have to put two other numbers, 4 and 10. With the 4, I'm looking at this inequality. Okay, so with the 4, is it open or closed? Closed. Now some students really have to rewrite it. They're like, well, I have to see it with the variable first. Well, if you do that, make sure you recognize when you write those two things down that the arrow's pointing at the 4. So when you rewrite it, you make sure it looks like that. Okay? So from that spot, I'm actually shading that direction. So I like to put a little arrow above it to show which way I'm shading. Because this one right here, x is less than 10, so if you want to rewrite it, is that open or closed at 10?
Open.
Open. And I'm shading to the left. So those two are pointing at each other, so it's caught in between. This is called an AND equation. Two things have to happen. This and this. It's like your parent, you ask, hey, can I go to the movie with my friends? Your parents say, yes, you can, if you clean your room and wash the dog. You're like, well, I'll clean my room. I didn't wash the dog. Well, you're not going. It's if you do this and this. It's not an or situation. It's an and. This also right here, for those of you who are starting to tune out, this is called a compound inequality. A compound inequality is always an and inequality. Okay, let me take that back. Not a compound inequality is always and, but the way we wrote it is always and. You cannot write an or equation, an or inequality like this. Okay? So I'll show that here in a minute. It's always an and, meaning it's always, your graph will always look like that. It'll always be a Mohawk graph. Okay? It's an and. Two things have to happen. Okay? Versus an or situation. So if I were to give you a situation, someone give me two inequalities. X is less than negative 7. Okay, greater than 6. So this is x is less than negative 7 and greater than 6. So tell your neighbor a number that's less than negative 7 and greater than 6. Yeah, can you ever have a number that's less than negative 7 and greater than 6? No, there's no such number. Therefore, this is called an or. This is an or. That means these two things cannot coexist. Now, sometimes or graphs can coexist. Usually not, but sometimes they can. Sometimes they're still or this. And that's when you would have you'd have everything shaded on your number line. Okay? And we'll talk about that here in a minute. But this right here, there is not a coexisting point here. Okay? So if I were to graph this, I'd put my negative 7 and my 6, and I would have my open circles, and this one shades this direction. This one shades that direction. It's an or. They look like the dude that's going bald in the middle. Sorry, man. No mohawk for you. You've got the outside hair and little bald spot. It's going to be me in about 10 years, probably. Sorry. Okay? That's it. That's the or. Okay? Two different things. Now, what I see as a common mistake is students go, well, I like the compound way. I just write it like that. So, look, McCoy, I'm going to go negative 7 and then x and 6. Just like you taught us in class. You always start with the smaller and you work your way to the bigger. And in between you put the variable. That's how you write your and, your compound. So what I do is I put that and then I have the arrow pointing to the x. All right? So I got it. And I got this one here and I have the arrow pointing to the 6. And look, it works. No, it doesn't, because this implies an and graph. You cannot write an or graph like that. Okay, this says this and this. So don't do this for an or graph. We frown on that. We don't put or graphs in that format. Okay? So if you see this format, that's an and. You automatically know your picture is going to look like this. If you have one of these or one of these and try to write it like that, you're doing it incorrect. Even though it looks like, well, look, I did it. See, I can do it. Well, you can, but it's still wrong. Right? It's like your friend saying, hey, man, I can do a 360, and they jump and turn about 30 degrees. And you're like, yeah, you can, but you did it wrong. It doesn't work. Okay? That's wrong. All right. We good there? Okay, let me give you an example of an or like this one. X is greater than 1 or x is greater than negative 2. Now that's an or where there's an overlap. Right? Two things, you're looking at it, and so sometimes your or graph, you have to recognize what they're saying. You're putting it here, and I've just told you, well, it looks like the dude that's going bald in the middle. Right? Well, the or graphs kind of change a bit because sometimes they could look like this type of situation where you have that or that. So really it means everything bigger than this. Yeah, it's just flowing to the side.
It's comb over.
Yeah, it's comb over. Okay. Got the comb over. Okay. Good. Thank you. All right, so think about what you're graphing. Everyone get that? Okay, everyone rate themselves 1 to 5. We're about to move on. I want to see where we're at. Okay, any questions? All right, very good. Let's take a look at this here. This is off your assignment. Okay, so if you'd like to, on number 1 here, You can do it on a separate sheet of paper. I'd prefer you do it in your notes and just write the answer on your assignment. You don't have to rework it again. Just put it in your notes. I'm assuming everyone is pretty good at these, but it's not good to assume, so try it out there. Okay. Looks like we're wrapping up. I'm going to go ahead and work this out, draw my line. And I have variables on both sides. I want to collect all variables on the same side. It gives me 0 minus 3 equals 3x plus 4. Subtract 4 on both sides. Get everything away from your variable now. Your 3x equals negative 7. And then divide both sides by 3. How many got x is equal to negative 7/3? Now, how many of you question whether you're right? You're like, dude, that's a fraction. I don't know if that. Everyone just took it for granted? You're good? Okay, well, that's good. I would always suggest plugging it back in. Just to, if you had time on your test, especially at the end, you're sitting there, just throw that negative 7/3 back in and check your work. If you do that, you should get the same amount on each side. That means those two are equivalent. So that's 2 times negative 7, or negative 14 divided by 3. Minus 3 equals 35/3 plus 4, right? The way you multiply a whole number by a fraction is 5 times 7 divided by 3. This times top divided by bottom. Okay, well, if you're like, that doesn't help much, well, think of 9 in terms, or 3 in terms of thirds. And the way you do that is you just multiply 3 times whatever you want to, whatever fraction you want it to be. So that would be 9/3. What's negative 14 minus 9? Negative 23/3. And here, thank you, negative 23/3. Okay, and here, what is 4 in terms of thirds? 4 times 3 is 12. So that's 12/3. 35 plus 12 is 47. Oops, I forgot that this is a negative. How about that? Negative 35 plus 12. Whew, that's a close one. Negative 23/3 equals negative 23/3. So we're good. It's correct. Okay, just a quick check. Any questions on it? Well, you know how to do those. Let's try to put them into a graphing calculator then. Okay? So in order to do that, we have to do some pre-work real quick. First set of pre-work I want you to do is I want you to think of this as 2 different equations. Okay, I'm going to take this side right here, and I'm going to say y equals that. Y equals x minus 7 plus 14x. And then I'm going to take this side right here, and I've got to think of that as y equals 4x minus 1. Now tell your neighbor mathematically, why is this a true statement going from this to this? Tell your neighbor. True. Expanding our thinking just a bit. Jaden? They are equal to each other, but how can I can write it, go from this form to that form? There's a certain mathematical principle or rule that you've used a lot in algebra. You've used it a bit this year. Parker?
Is it like transitive property?
Yeah, I think you could apply it there. I'm thinking more of substitution. How many remember substitution? If y equals this and y equals this, then that can be plugged in for that y, right? So what this equals that. You can also undo that. Y equals this and y equals that, which is beneficial to you if you think of this as like y sub 1 and this one as y sub 2 or vice versa. Okay, it doesn't matter which one you call 1 or 2. But in your graphing calculator, if you go to your y equals menu, and notice on mine, I've got a bunch of junk in there from before, so I'm going to hit clear. I'm going to turn my plot off. Notice there's a plot on up there. I'm going up there and hitting enter. I'm turning that off. I'm going to go down here in y sub 1. I'm going to put in 4x minus 1. Y sub 2, I'm going to put in x minus 7 plus 14x. Okay, and now I'm going to hit graph. and it's not going to show much of anything because I'm still zoomed in to where my stat plot was. I see a little piece. So what zoom do I want? Yeah. Zoom standard. Zoom 6. That brings you to your normal viewing window. Okay, now I'm going to pause there because I went pretty fast. How many are still with me right now? How many are stuck somewhere? Okay, how many are with me then? Okay, well, they're there then. So everyone has that picture. Now, really, if you want to know where these two things are equal, when you're graphing two lines, if you remember back to systems of linear equations, where is their point that's equal? Where do you know two lines are equivalent? Connor?
Where they cross.
Where they cross. Jaden, that what you're going to say too? Yeah, they're where they cross, right? Now, that's not easy to see. So it's helpful if we zoom in. So what I'm going to do is I'm going to go zoom, and I have a lot of options here. You can zoom in, but I'm going to use zoom box. Box is kind of cool because if I hit box, it lets me draw a box around the area that I want to zoom into. Yeah, I hear you. Just you're going to have to wait at the door. I don't know who that is. All right, so we're going to hit enter, and we're going to draw a box. Okay? Well, you just move your cursor. Yeah, I'm sorry. You guys can't see that. When you're drawing your box, you're just moving this cursor around a bit. Okay? So there we go. Whatever box you draw on it, and when you hit enter, it's going to zoom into that piece.
How do you undo it?
You go back to zoom standard, and then go zoom box again. Okay? Just set it on my desk, please. Thank you. Thank you. Okay, how many are there?
Almost. It's loading.
All right, I'm going to pause. Okay, so what we're going to do is we're going to calculate the point of intersection. Now, you could use trace and try to estimate it. I'm not going to use my trace, though. I'm going to use the piece right above it that says calc. So I'm going to go second. Everyone should be with me now. Okay, second trace or second calc. And I want to calculate the point of intersection. Okay, so which one is that? 5. Number 5. Okay, and then it starts asking you questions. It's saying, first curve? Well, most of your graphs you'll do this year are curved lines. Just so happens right now we're in linear equations. Most of them are curved lines. So when it's saying first curve, it's saying, what is your first equation? And they're saying, is it this? And you're like, yeah, sure. You hit enter. Second curve, is it this? Yep, because you only have 2 in there. So it's just going to those. If you had more, it'd keep asking. You could keep switching through. And then it says guess. Just for fun, guess. That's not really why they have you guess, because it's because later in the year when you're studying other curves, you'll have multiple points of intersection possibly. It wants you to put your cursor closest to the point of intersection you want. In this case, there's only one point of intersection, so you really don't have to do anything other than hit enter. And it'll tell you the point of intersection is at x equals 0.54545455 and y equals this. Now, what are we trying to solve for? X. So our solution is 0.5454, or x equals 0.54 repeating. Huh?
So how did you get the intersection again?
Second calc.
Yeah.
Intersect. First curve, second curve. You guys didn't get it that, you're going to have to check it out later online or we'll run out of time today. Okay? Yeah?
It says to round each answer to the nearest.
Nearest tenth. So that would be x equals 0.5. Okay? Nearest tenth. Approximately now. Hey, one other thing, just so you know, if you ever want to change that to like a fraction, okay, if you go 0.545455, okay, and then you push the math button and select option 1 and hit enter, it changes it. It's 6/11ths. Okay? Now, if you didn't get that, once again, you're going to have to go back and watch that later. Okay, so what I'd like you to do right now, I want everyone to take a look at example number 2. I want you to do this one, that one, and that one. Actually, and that one. 19, 20, and 25, and 27. Don't worry about 29. Ready to go? Just a quick reminder, I'm a big stickler about showing work. The work I need to see for number 19 isn't much. I just need to see that x is greater than negative 10. That's it. Or excuse me, negative 2. Unbelievable. Good thing I left a little room there. X is greater than negative 2. You divide both sides by 5. Okay? On number 20, not much work I need to see. However, a rule for you to remember is when you multiply or divide by a negative, what happens? The sign flips. And I heard a few of you talking about that when I was walking around. Yeah, whenever you divide by that negative, that sign flips around. It flips over. Okay? If you're not sure why, just remember, you could agree that 1 is greater than 2, or excuse me, negative 2. If you were to change this and multiply this both sides by a negative number, say if we multiply both sides by negative 3, which is legal in math, when you do that, that gives you negative 3 now, and that gives you positive 6. This sign wouldn't be true any longer. You'd have to flip it over. Okay, that's what happens in these cases. Okay? Number 25, for those of you who don't know how to get rid of decimals and you're not a big fan of using decimals, remember if you look at it and you say, well, each decimal has one place value, that means I could multiply everything by 10 and just move that decimal over. That's what happens when you multiply each term by 10. So really you have 31x plus 2 is less than or equal to 33. That's equivalent to 3.1x plus 0.2 is equal to 3.3, or is less than or equal to 3.3. And then from there, you just solve it the same way. Now, I don't need to see that you write down the minus 2. I need to see this. If you're going to do that, I need to see then this line. And then I need to see that. So those three things, that would be showing work for me. If you're going to do this. Maybe you didn't do that step. Okay? Dylan. Well, that's how I keep track of my work. Yeah, I would show that line. That's just me. I don't need to see this line drawn if you don't want. But you better keep yourself organized. If you don't know how to put your inequality or equal sign in the same spot every time, then draw that line. Okay. Number 27, how do you get rid of fractions? You multiply by the common denominator. Now, in this case, this negative sign can be attached anywhere. I could attach it up here or attach it down here. For the sake of this problem, I'm going to bring it to the bottom. So I'm going to think of this as 1x over negative 2 minus 5 is greater than 2x. Okay? And I'm going to get rid of that whole fraction by multiplying every term by 2. That by 2, that by 2, and that by 2. What happens then is it's going to get rid of this fraction. And if I multiplied it by negative 2, it'll get rid of the negative at the same time. Okay? So in this case, if I multiply by negative 2, it's going to get rid of that negative. It gives me positive x. Negative 5 and negative 2 is positive 10. What happens with the sign when I multiply by a negative? Flips. Negative 4x. Now you don't have to do it this way. Collect all your variables on one side. I'm going to move that over. I get negative 5x now by subtracting x on both sides. And then divide by a negative again. X is, we flip that sign, negative 2. Negative 2 is greater than x, or x is less than negative 2. How many got it? Questions there? Okay, last piece is solving and graphing absolute values. Okay, now remember, when you're dealing with an absolute value, you're dealing distance from 0. What number is 6 units from 0? Or negative 6 units from 0? Negative 6 units from 0. How many of you have traveled a distance of negative 6 units in your life?
Maybe.
No one has. This is no solution. Absolute values cannot equal negatives. This says how far away from 0. So list the number 6 units away from 0. That's what that's saying. That's not possible. Absolute values cannot be negative. Okay? That's no solution. However, like if I do this one, this says give me a number that when I add 3 to it is 4 units from 0. So the easier way to do that is to move that 3 over, subtract it over here, and say, okay, this is actually 1. Give me a number that's 1 unit from 0. Well, 1 is 1 unit from 0. What other number is 1 unit from 0?
Negative 1.
Negative 1. Remember, you've got to do a positive and a negative case. This is the positive case, 1. The negative case is negative 1. So x is equal to plus minus 1.
So when it says graph, do you want to do that number line thing?
That's what you do, yeah. Plus it'll help some of you with the pictures.
You want shade on that one?
No shade, no inequality symbols. You only shade with inequalities.
Oh. Yeah.
This one, the inequality's already, or the absolute value is already by itself. So we need to think what numbers are 2 units from 0. So think of your number line again. If I have 2 units from 0, what number am I talking about? Well, and now I'm not graphing yet, I'm just thinking to myself. 2 is 2 units from 0 and negative 2 is. So I've got to say what will make this equal 2 or negative 2. So you've got to do a positive case. When is 4 minus x equal to negative 2? And when is 4 minus x equal to positive 2? You're doing your 2 cases. Okay, right? Because this could be, this number in here could be negative 2 or 2. So you take this and say negative 2 and positive 2, and you take what's in here and you solve. What makes this negative 2? Yes, subtract 4, you get negative x is equal to negative 6, so x equals 6. Here, subtract 4, you get negative x equals negative 2, so x is 2. So if I put 2 in here, that would give me 2. Or excuse me, yeah, if I put 2 in here, that would give me 2. And if I put 6 in here, that would give me negative 2. And the absolute value of negative 2 is 2. So my solutions are 2, so I can put a dot there, and 6. I can put a dot there. X equals 2 and 6. Just remember to get your absolute values alone first. Okay? Any questions there? So like on number 41, you have to do what first? Tell your neighbor. Add 5 to both sides first. Okay? Get it to this, and then you get x is equal to, or absolute value of x minus 4 equals 3. Do your positive and negative cases. All right, last piece. Solve and graph each inequality. We got to do a positive and negative case. Positive says
X plus 2 equals greater than, or positive.
x plus 2 is greater than 5. Negative case is x plus 2 and you have a negative 5. Now remember, when you do a negative case, make sure you flip the sign. So that flips over. That's now there. Okay, so if I solve this, I subtract 2 on both sides, I get x is greater than 3. Here I subtract 2. X is less than negative 7. When I graph, that's 0, that's 3, that's negative 7. They are both Open circles. The 3 shades that direction. This one shades that direction. How many of you have ever played volleyball?
Maybe.
Think of this as a volleyball court. The arrow's pointing outside the volleyball court, right? Everyone see that? The arrow's pointing out. That means you're going to shade outside. Here, the arrow's pointing in. That means your shading better be inside on this one. Your assignment's evens. On the example side, cross out the mix. Evens on example, cross out the mix.